Let's go ahead and finish this problem, which we started in the previous video. Okay, so there is a part D. So go ahead and click continue. Okay, and part D says, what can you conclude from the results of A, B, and C? Okay, so for the original data set, the sample mean was 46.3, and then the sample standard deviation was 8.6. Okay, and you notice that in part B, right, after we give each employee a 5% raise, it changed the sample mean and sample standard deviation slightly. Okay. Now, if you take 46.3, okay, which is the sample mean of the original data, and multiply it by 1.05, okay. Right, so in other words, doing that increases the sample mean by 5%. Right, we get the number 48.6, okay, which is what we got. Okay, and we did that by increasing the salary of each employee by 5% and then taking the mean, okay, and we got the same result. Okay, so when you round this to the nearest tenth, right, we get 48.6. Okay, likewise, if you take the sample standard deviation of the original data set, which is 8.6, multiplied by 1.05, okay, we get that number 9.03. Okay, it's not the same, but basically the sample standard deviation also increases by 5%. Okay, so in part C, we took each of the salaries of the employees and divided them by 12, and then we found the sample mean and sample standard deviation. Okay, you can go back to the spreadsheet to kind of remind yourself what we did there, what the numbers ended up being. Okay, so basically the mean of the original data set was 46.3. So right, if we divide that mean by 12, right, we should get the mean that we got in part C, right, which was, when you round it, is about 3.9. Okay, so 3.858333, when you round it to the nearest tenth, right, we get about 3.9. Okay, so what you want to do is select the appropriate answer choice that summarizes our observations. Okay, now obviously it's not going to be answer choice C, because answer choice C says that when we multiply by a constant, the sample mean and sample standard deviation remain unaffected, right? So that wasn't the case. Okay, what is the case is that when we multiply by a constant or divide by a constant, so when we multiply every data value in our data set by some constant or divide by some constant, okay, the new sample mean is that constant multiplied by the sample mean of the original data set. Okay, that's what this says. And likewise, the new sample standard deviation is whatever that constant was, right, multiplied by the standard deviation of the original data set. Okay, and that's what we observed, right? So by increasing each of these values by 5%, it likewise increased the sample mean and sample standard deviation by 5%. Okay, and by dividing each of these by 12, right, it divided the sample mean and the sample standard deviation by 12, and we got these numbers here. Okay, so it looks like answer choice B would be the most appropriate answer choice. All right, and that completes question 8. So let's go ahead and do one more question. So question 9 introduces the concept of what's called the coefficient of variation. So you can do that one on your own. Question 10 is about the same topic of the coefficient of variation. So we're going to do question 10 together in this video. So before we attempt this question, right, let's go to the book. Okay, and at the top of page 92 in section 2.4, it describes what the coefficient of variation is, and then tells you how to calculate it. Okay, so to compare variation in different data sets, you can use the standard deviation when the data sets have the same units of measure and have means that are about the same. Okay. No, obviously, right. That's not always going to be the case. Like with data sets that you deal with, right? The data sets are not going to have the same units of measurement, and they're not going to have the same means. So for data sets with different units of measure or different means, okay, we're going to use the coefficient of variation to compare the variation between two data sets. Okay, and these are the formulas that you're going to use. They're actually the same formula, right? One's for the population, right? If you have data for the entire population, okay, and the other formula is for sample data. Okay, so the coefficient of variation, abbreviated CV, of a data set describes the standard deviation as a percent of the mean. Okay, so essentially both these formulas are the same. Okay, so the coefficient of variation is found by taking the standard deviation, dividing it by the mean, and then multiplying the result by 100%. So that's how you calculate the coefficient of variation. Okay, once again, the coefficient of variation allows us to compare the variation of two data sets that have different units of measurement. Okay, the data set with the higher coefficient of variation will have greater variation than the other data set. Okay, let's go ahead and take a look at the problem. Okay, so we have sample grade point averages for 10 male students and 10 female students. Okay, so we're going to find the coefficient of variation for each data set, and then compare the results. All right, so we're going to go ahead and copy over this data into StackCrunch. Okay, so we've got a lot of previous work here, so we can close out some of these windows. All right, and if you want to reference any of your previous results, after you've closed them, you can go to StackCrunch, so the menu called StackCrunch, and then show any results that you want to see. Okay, by clicking on the name of those results. Okay, but in any case, I'm going to move this over so I can see more of the spreadsheet. Okay, and I'm going to go ahead and paste the data. Okay, so I want to start it at the very top. So I'm going to click on the very top row. Okay, so the data for the males is here, and the data for the females is here. Okay, so let's remind ourselves what we're going to do to answer the question. Okay, so going back to the book. Right, remember the coefficient of variation, right, is equal to the standard deviation divided by the mean. Okay, so since we're dealing with a sample of data, we're going to use this formula. So S is the standard deviation, and then X bar is the mean. Okay, so for both these data sets, we want the standard deviation and the mean. Okay, so we're going to select both of the columns. Okay, get the mean and the standard deviation. Okay, and we're going to apply the formula. Okay, so we're going to take the standard deviation and divide by the mean and then multiply it by 100. Okay, I'm going to do this for the males first. So the coefficient of variation for the males is blank percent. Let me move this box over so we can see it. Okay, so the standard deviation was 0.707, 42098. Okay, and we're going to divide that by the mean of 3.16. Okay, and we get that nice long decimal there, so 0.223. Okay, by the way, we need to multiply that by 100, so don't forget that part, so multiply that by 100. Okay, so it's 22.38. Okay, or about 22.4% when you round it. Okay, so we want to round it to 1 decimal place, so 22.4%. Okay, and we're going to calculate the coefficient of variation for the females. Okay, so the standard deviation for the females is 0.85531.021, and we're going to divide that by the mean of 3.16. Okay, and then we're going to multiply that result by 100. And we're going to round that to 1 decimal place, so that 0 there is going to get rounded up to a 6. Or, the 0 is going to get rounded up to a 1, not a 6. Okay, so it becomes 27.1%. Okay, is the coefficient of variation for the females. So 27.1%. Okay, so it says compare the variability of grade point averages of males and females, and then choose the correct answer. So like I mentioned earlier, the higher percentage is going to represent the data set with more variation. So it appears that the GPAs of females are more varied than the GPAs of males. Okay, so we're going to select the appropriate answer choice. Okay, which appears to be answer choice A, so be sure to read them carefully. Okay, and that completes question 10 and the homework for section 2.4. Thank you for watching.